Section 7.5 Step response of an RC circuit. You can find a circuit on the slide and you will find it is quite different from the previous ones because there is a source inside and there is a switch inside the circuit as well. But the switch is operated at t equals 0. However, on the other hand, the capacitor is charged. So when t is less than 0, the voltage of the capacitor is not 0. Actually, V0 minus equals V0 plus equals V0. Why? Because the voltage across a capacitor cannot change abruptly, so the two voltages are the same. And then when t is greater than 0, we can get this equation according to KCL, which is C multiplied by dV over dt plus V minus Vs multiplied by ut over R equals 0, where ut is the step function, which means the source is added into the circuit when t equals 0. Then we can try to solute this function and we get dV over dt equals minus V minus Vs over Rc. And then if we integrate both sides, and we can find the solution. So what is the step response? The step response of a circuit is its behavior when the excitation is a step function, which may be a voltage or a current source. So with the step function, we can redraw the circuit as a graph B, and we can get rid of the switch by using the step function ut. Now let's continue to solve this function, and finally we get the solution as V minus Vs equals V0 minus Vs multiplied by e to the minus t over tau power, where tau equals Rc. And you can find the time constant tau is just like the source-free RC circuit. And then we can rewrite the solution as this: Vt equals Vs plus V0 minus Vs multiplied by e to the minus t over tau power when t is greater than 0. And finally, we can write the full solution as below: Vt equals V0 when t is less than 0, and Vt equals Vs plus V0 minus Vs multiplied by e to the minus t over tau when t is greater than 0. And we can find the curve in the graph. And you can find when t is less than 0, the voltage keep as V0. And when t is greater than 0, the voltage is increasing when t is increasing. However, the final value of the voltage is the Vs, which is the voltage of the voltage source in the circuit. If we assume the capacitor is uncharged initially, so we can set V0 equals 0, so that we can get another solution which is different from the previous one. When t is less than 0, Vt equals 0. And when t is greater than 0, Vt equals Vs multiplied by 1 minus t to the minus t over tau power. And we can rewrite this solution as Vt equals Vs multiplied by 1 minus e to the minus t over tau multiplied by ut, where ut is the step function. And then we can use the relationship between the current and the voltage of a capacitor to find the current through the capacitor, IT equals C over dV over dt. IT equals C multiplied by dV over dt equals C over tau multiplied by Vs multiplied by E to the minus T over tau, where tau equals RC when T is greater than 0. And we can rewrite the solution as IT equals Vs over R multiplied by E to the minus T over tau multiplied by UT. And we can draw the curve in this graph, and we can find the difference between the voltage and the current of a capacitor from the two graphs. And you can find the voltage cannot change abruptly. However, the current can change abruptly. Actually, the complete response of a RC circuit can be divided into two parts. The first part is natural response, which is caused by the stored energy in the capacitor. And the second part is forced response, which is caused by the independent source. So we can write the voltage of the capacitor like this. V equals Vn plus Vf. Vn is a natural response and Vf is a forced response. Vn equals V0 multiplied by E to the minus T over tau. You can find there is no value of the independent source inside Vn. Vf equals Vs multiplied by 1 minus E to the minus T over tau, and you can find it has no relationship with the energy stored in the capacitor. On the other hand, the complete response of an RC circuit can be divided in two parts like this. Complete response equals transient response plus steady state response. The first part is temporary part, which means it will disappear when time is large enough. The second part is permanent part, which means it will stay forever. In this way, we can write the response like this. V equals Vt plus Vss. Vt is a transient response. Vt equals V0 minus Vs multiplied by E to the minus T over tau power, and Vss equals Vs. The transient response is a circuit temporary response that will die out with time. However, the steady state response is the behavior of the circuit a long time after an external excitation is applied. So we can rewrite the complete response like this. Vt equals V infinity plus V0 minus V infinity multiplied by E to the T over tau. So you need to remember this equation, and you can use it to solve the step response of an RC circuit. So to find the step response of an RC circuit, you require three things. The first one is the initial capacitor voltage V0. The second one is the final capacitor voltage V infinity. The third one is the time constant tau. After you get the three things, and you can use the equation to get the answer. What if the switch is operated at t equals t0? And you can use the equation like this. Vt equals V infinity plus V t0 minus V infinity multiplied by E to the minus t minus t0 over tau. This is the end of this section.